Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll start Chapter 7 on Categorical Data Analysis. And I recommend, as always, opening the R code file and following along running the code throughout the chapter. In this chapter, you will learn how to select the appropriate statistical method to compare summaries from categorical variables, assess the assumptions of one-way and two-way tests of proportions and independence. Assumptions are always really important. I stress them all the time because without knowing whether your model assumptions are met, you can't know whether to trust the inference you're making. To decide whether the proportions between populations are different, including in stratified and cross-sectional studies, and finally recommend action based on the decision coming out of a hypothesis test. All right. What is categorical data? Categorical data, imagine you're taking a random sample from a population, and the random variable you're interested in can fall into mutually exclusive and exhaustive categories. For example, a simple case might be gender, so male, female, or species of an organism, or colors. If you're taking colors in sort of a discrete binning situation, for example, on your driver's license, whether you have blonde hair, brown hair, black hair, things like that. And so those are categorical variables. And we want to understand in categorical data analysis whether the proportions that fall into these categories are different or follow a certain pattern or are different between populations. And so that's what we're going to explore in this chapter. As a fairly sophisticated and complicated example, let's start by visualizing some complex categorical data and see what sorts of questions naturally come up. So the sinking of the Titanic, the British ship, is a famous event and still a movie I've never seen. And books are still being published. There's lots of well-known facts which are somewhat questionable historically, and whether some of the policies actually worked. For example, women and children first. All right, so the data source that we're going to use provides data on 4 variables: the class of the passenger, first, second, third class or crew, the sex, male and female, the age being child or adult, and then the survival status, whether yes or no. And so we've got 4 different categorical variables, and each person aboard the ship falls into a set of categories along these 4 dimensions. So I'm going to show you there's a library that comes with R called datasets, and there's lots of data sets in there. I find that they're somewhat simplistic, but for fairly simple examples in statistics, they can be quite useful. And this data set is called Titanic. And by running data Titanic from the data sets, we get this new object called Titanic that is, in this case, a 4-dimensional array or table with these 4 variables: class, sex, age, and survived. And I'm going to let's look at this briefly. So when we output this, there's actually 4 dimensions being plotted, but you can only look at 2 dimensions at a time. So for age, for children who did not survive, along the columns of the table are the sex, male and female, and then the class. So first, second, third class, and crew. So there weren't any children crew, and these are children who did not survive, and those are only the third class children. Okay. I'm just going to jump down for a second to children who did survive. All right, and here are the sex and the class, and you can see children who are first and second class did survive. Some third class children also survived. And so that's how to read this data. We also have adults who survived, and if I page back up again, we have adults who did not survive. Okay. I'm going to use the Reshape2 library to melt the data into a data frame. And so here's all the combinations. We've got class, sex, age, and survived as columns, and then the frequency for each of those. And so that four-dimensional array can be reshaped into a long table. And this is the format that's going to be more useful for us to do the analysis. And in this case, I'm not going to worry too much about analyzing the data, but just visualizing it. There is, so I'm going to create an additional column called color, and it's going to have these two colors. It's a sort of a light purple and light blue color. And we're going to look only at adults and look at their survival. So there is a function called parallel set. I think it's a function that there's code on the website. So in fact, let me just quickly jump over to the website for Chapter 7, the R code. I'll open this in a new tab. And actually the first code you see is a function called parallel set. I'll make this a little bit bigger. That defines a function. It's somewhat of a complicated function because it has to figure out how to draw stuff, though it's not that long. It's only maybe 20 or 30 lines long. And it's a matter of figuring out how to draw polygons, okay, of different colors. And so it's at this point that the code from that appear in the notes starts. All right, let's go back and look at this parallel set plot. So this function, we have survived, sex, and class, and we're going to plot the frequencies in different colors. All right, so there's the plot. Now to interpret it. The first row is whether they survived. No, no, or yes. And you can see right away that the length of this line is proportional to the number of people. So about twice as many people did not survive as survived. And it's the survival status that is colored. Okay, so purple is that they did not survive, and light blue is that they did survive. On the next line is the sex. We have males, and there's almost 80% males and about 20% females. And then you can see what proportion of the males and females actually survived. And a sad situation for those of us with Y chromosomes, only about 20% of the males survived, whereas maybe about almost 3/4 of the females survived. So women and children first. Looks to some degree that this is working out for those folks. And then finally, the class of the passengers. So we have first class, second class, third class, and fourth class. We have an indication here of the male-female composure of each class by where these bands of color are coming from. So in first class, it's about 1 inch wide, and just maybe about 40% of those are coming from male, and then the rest are coming from female. And we've got second class, third class, and crew. And one thing that you can notice is the proportions of these lines for crew for survival. So we're talking about maybe, let's see, so survival is the blue. So we've got about 60% survival for first class, maybe about 40% survival for second class, maybe a little bit less than that, 15% or so for, 40%, maybe this is about 20% third class, and maybe this is about 1/4 of the crew surviving. So there's definitely some bias that you want to be in first class, you want to be a female, and of course you want to survive. So that's the situation. And so a visualization like this, you can imagine reordering these rows. You can also plot the children, not just the adults. You might color it by sex instead of survived. So you can make some decisions there about how you're going to visualize it. And then lots of questions can come up just from the visualization. And in the rest of the chapter, we're going to learn how to test some of those hypotheses, so answer some of the questions, as well as make estimates of these proportions with the appropriate uncertainty, often with a confidence interval. So types of questions are: how likely were people survive such a ship in sinking in cold water? Okay, so the probability of survival is just sort of along that top row. Looks like about a third, right? Is the survival proportion dependent on sex, class, age, or a combination of these? So we sort of explored that a little bit, and certainly there are some dependencies that your probability of survival depends on your sex and your class, and probably also depends on whether you're an adult or a child as well. And how different is the survival proportions from first-class females versus third-class males? Okay, so that's a very specific hypothesis that we could test directly. So it's those types of questions that we're going to be answering as we continue with the next video.